Welcome to the Explainer. Today, we're diving into the story of computer memory. You know, that short-term workspace, the RAM, that makes everything you do on your computer even possible. And let me tell you, its journey is absolutely incredible.
I mean, it really does feel like magic, right? The idea that a machine can just hold on to information, process it, and then recall it in an instant. But, it's not magic, not at all. It's actually the result of this amazing journey of innovation that started way, way back.
So, here's the game plan for this explainer. We're going to trace the evolution of this working memory. We'll kick things off with the very first electronic spark, then jump to the era of giant mainframes, and we'll wrap up by looking at a future that is, well, it's almost unimaginably small.
All right, first things first. Before we get into the nitty-gritty history, let's just make sure we're on the same page about what memory even is. Now, we're not talking about long-term storage, like your hard drive. Think of it more like the computer's immediate workspace, kind of like the top of your desk where you have all the papers and tools you're using right now.
Exactly. This is the active, thinking part of the machine. It's where all the action happens, where calculations are crunched and programs actually live while you're using them. And believe it or not, its origins are super humble. It all started with a really simple but really tough question. How in the world do you hold on to a fleeting electrical charge?
Okay, so our story kicks off way before silicon chips were even a glimmer in someone's eye. We're talking vacuum tubes and a flash of genius back in the late 1930s. This is long, long before a computer was something you'd find in a home.
So this machine, the Adanasoff-Berry computer, or ABC, was a total game changer. Now, to be fair, it was never fully finished, and it wasn't a do-everything kind of computer. But that's not the point. The point is, it introduced this absolutely revolutionary idea. You could store information not with clunky mechanical gears, but with pure electricity. Okay, so here's the tricky part. Atanasoff was trying to store data using an electrical charge. But a charge, by its very nature, just wants to fade away, right? It leaks, it disappears. So what was his solution? This incredibly clever idea called regenerative memory. Basically, he built a circuit that would constantly read the data and then immediately write it right back, over and over again. It was like constantly refreshing the information before the computer had a chance to forget it.
And get this, what's so amazing is how ahead of its time this whole idea was. That basic principle, using capacitors to hold a charge that you have to keep refreshing, well, that is the exact foundation of the dynamic RAM, the DRAM, that's sitting in your laptop or your phone right now. It's nuts. It all started right here.
All right, let's fast forward a bit. We're moving into the 1950s, the era of these giant room-sized computers. And that whole problem with the fading electrical charges, well, it needed a much more stable, a much more robust solution for these first-generation commercial machines.
So yeah, Atanasoff's big idea, his concept of electronic memory, it was picked up pretty fast by the early computer giants like ENIAC. But by the mid-50s, engineers came up with something even better, something more robust that didn't have to deal with constantly babysitting a delicate little electrical charge.
And this was a huge leap forward. Instead of a charge that could just vanish, they came up with magnetic core memory. Picture these tiny little magnetic rings, or cores. You could magnetize them in one direction for a 1 and the other direction for a 0. And they had these superfine wires threaded through the rings that could flip the magnetic state to write data and then sense that state to read it. The best part? It was stable. It would even hold on to the data if you unplugged the machine. This is what made those early mainframes reliable enough to do really important work.
And just look at this picture. This really drives home the scale we're talking about. Every single one of those massive cabinets, that's all part of one computer. And all that hardware, all that complexity, it was needed to store what today would be just a few kilobytes of data. We're talking enormous, complex, and seriously power-hungry machines.
So suddenly you've got these giant machines that can store thousands and thousands of pieces of information. Which, of course, brings up a new question. How do you even measure all that information? Well, it turns out the answer lies in a really, really simple binary language.
It all starts here, with the bit. You can think of it as the fundamental atom of all digital information. It's just a single on or off state, a 1 or a 0. In that magnetic core memory, it was the direction of the magnetic field. And at Atanasoff's early machine, it was whether a capacitor had a charge or not. Literally everything a computer remembers is built up from this one simple building block.
Okay, so if a bit is an atom, what happens when you group them together?
Well, if you string 8 of these bits together, you get a byte. And with those 8 slots for ones and zeros, you suddenly have 256 different possible combinations. That's enough to represent every single letter, both uppercase and lowercase, plus all the numbers and symbols you need. And just like that, this is how text is born from simple ones and zeros.
And from that single byte, well, we just keep scaling up. We go to kilobytes, then megabytes, gigabytes, and way beyond. You want some perspective? The memory in the smartphone that's probably in your pocket right now can hold billions of times more information than one of those entire room-sized mainframe computers we just saw. The growth has been, well, it's just astronomical. There's no other word for it.
So, we've basically mastered memory on a large scale. The next great frontier, the next big challenge was, and honestly still is, to make it unbelievably microscopically small. The quest for more and more density is always on.
Now think about this for a second. We're talking about 1959, back when mainframes were still using those hand-woven magnetic cores. And yet you have this visionary physicist, Richard Feynman, already asking the ultimate question. What's the absolute physical limit of storage? And his answer, his proposal, was the atom itself.
Just let that sink in for a second. He's saying the entire written history of humanity. We're talking the Library of Congress, every library on Earth, every single book ever published. Feynman did the math, and he figured if you could use just a small handful of atoms for each bit of data, all of it would fit inside a tiny cube of material so small you could barely even see it.
So how small are we talking? About the width of a single human hair. That was the theoretical limit he laid out over 60 years ago. And the wildest part is, today, this isn't just some sci-fi theory anymore. Researchers in nanotechnology are getting closer and closer to that level of atomic control. Scientists are even looking at using DNA, the code of life itself, as a way to store data. They're literally making Feynman's incredible vision a reality.
So this entire incredible journey, from clunky vacuum tubes all the way to the very real possibility of storing data on individual atoms, it leaves us with a really fascinating question for our future, doesn't it? If we reach a point where we can store everything, what actually becomes important? What do we choose to remember? And maybe more importantly, what do we allow ourselves to forget? Thanks for joining us for this explainer.